I will be moderating today's quarterly research seminar, and I'm assisted by Dr. Ankita Arvan, Research Assistant Professor at FIU, who is managing the web room. I'm also joined by Jamal Al-Kaisieh with Federal Highway Administration and Paul Wiles, former Georgia State Bridge Engineer. Jamal and Paul will be moderating the question and answer session following the research presentation. Our director is Dr. Atorad Aziz-Namini, and our research seminar moderator is Islam Manatwe. Atorad and Islam send their regards and regrets for not being able to join us today, as they are both traveling internationally. We thank you for joining us today for our quarterly research seminar featuring a presentation on a comprehensive decision support tool for accelerated bridge construction, considering safety, social equity, and environmental justice. Our presenters today are Ali Ibrahimian, PhD, and Nasim Mohammadi-Yazar, MS and graduate student, both at Florida International University. Before we start the presentation, Atorad has asked that I remind everyone about the 2024 World Bridge Engineering Conference that will be held on December 11th through the 13th of this year in Miami, Florida. The early bird registration deadline is rapidly approaching. Please get registered soon to take advantage of the early bird pricing. You can register at the website link that is shown on the screen. We are co-sponsored by 33 state agencies, and the program has been set. You can review the link that is provided on the screen to look at the details of the program. But in short, we have 9 keynote talks, and there are 140 30-minute long technical presentations. In addition, there is a Shotcrete UHPC workshop. And as we mentioned on the previous slide, you can find all of that detail at the link to the program that has been published. The keynote speakers are shown on this slide. It's truly a who's who of the innovative bridge technology and accelerated bridge construction community. I'm really looking forward to these presentations, and I really hope you all join us. On Wednesday evening, there will be a reception with entertainment. Thursday evening will be the Shotcrete workshop. This slide includes a number of helpful links regarding hotel reservations, exhibit and travel scholarship opportunities. So please look at the links that are on the screen to find out additional information about those. Also know that these slides will be posted on the archives at the IBT-ABC UTC website with this research seminar, so you can look up all of this information later. But also know that it's really easy just to look up the ABC UTC and find additional conference information. And now to today's feature presentation. We'll be learning about decision-making tools for accelerated bridge construction, taking into account considerations that have been generally used by states, such as cost and schedule, but adding the additional considerations of safety, social equity, and environmental justice. We welcome Dr. Ali Ibrahimian, who's an assistant professor and principal investigator at our own Florida International University. Ali is joined by Nasim Mohammadi-Yazar, who is has a Master of Science and is currently working on her PhD, also at Florida International University. Upon conclusion of the presentation, there will be a question and answer session. Please enter questions in the chat box in your webinar dashboard. And now I will turn the presentation over to Dr. Ibrahimian. Thank you for joining us.
All right, great. Hello, everyone, and thank you for having us here. My name is Ali Ibrahimian. I'm an assistant professor with the Department of Civil and Environmental Engineering at Florida International University. And today, together with Nasim Mohammadi-Yazar, my PhD student who has been working hard on this project over the past couple of years, we are going to be presenting the tool, the decision support tool that we have been able to develop. And there are some new aspects in this decision-making tool comparing to some of the other existing tools. And more specifically, this is the first time quantification of ABC benefits, accelerated bridge construction benefits for improving work zone safety and incorporating that benefit into this decision-making tool. Also, we have tried to incorporate aspects of social equity and environmental justice into the ABC planning and decision-making. So before I start the presentation, just wanted to let you know that you all have access to a PDF copy of these slides here. You probably can download that from the handout section on your dashboard. And then through this link that you see here, you'll have shortly after this presentation, you'll have access to the actual tool, which is basically an Excel file. And also soon in the future, we'll be uploading really step-by-step user's guideline for using this tool plus some training videos. So stay tuned for that, and please check out this link later for additional materials. As a problem statement, very quick problem statement. There are currently more than 600,000 bridges in the country. And according to the latest databases from the US DOT's National Bridge Inventory, and some of the studies and analyses by the American Road and Transportation Builders Association, more than 30% of these bridges need some sort of repairs or even replacements. So that shows that we need really more effective, cost-effective, and also rapid construction techniques. And that's probably when ABC can come into play. But ABC decision-making is really challenging, and that's primarily because of the existence of multiple criteria that most of the time are conflicting. And that includes budget, cost, and a lot of other criteria or challenges related to structural, traffic, and site conditions of the bridges. And it can get even more complicated if we want to include safety and social environmental aspects here. So the answer is we really need a decision support tool to help our decision makers to overcome these challenges. Otherwise, with this pace and with this budget limitation that we have, it takes a lot of time for the country, maybe 75 years, depending on the current number of bridges that needs rehabilitation or replacement. Okay, then talking about accelerated bridge construction, we're really talking about aspects. It's not just about reducing the construction time or the project time. It's actually about using innovative planning, design, materials, and construction methods that can be used to construct bridges in less time. So these are the benefits recognized by the Federal Highway Administration, FHWA, and as you see here, they're talking about safety, quality, longevity of our projects, and even social and environmental aspects. And what we are doing is really trying to incorporate as much as these aspects into the decision making for our projects. Well, currently, state departments of transportation across the country use different approaches for decision making about the suitability of adopting ABC methods in bridge projects. These approaches vary in a range of very simple approaches, including questionnaires, flowcharts, simple tools, going all the way to more rigorous and time-consuming methods, including the decision making software tool by the FHWA that works based on the AHP or analytical hierarchy process method. So different state DOTs have their own procedures. Some of them are using one-step method, two-step methods, three-step methods to come up with a planning method, to come up with a decision-making method for identifying the bridges that are appropriate to be used with ABC methods. And here's a link if you want to the FHWA tool, which was developed in 2012 through a collaboration with some other state DOTs. So we did a review of the existing tools try to see the benefits, the pros and cons of each tool. And we finally ended up with going ahead with the Connecticut DOT tool, because Connecticut DOT is using a middle ground approach. It's the method is a one-step method, and it's actually a tool. It's a spreadsheet-based tool. It's an Excel file that the decision makers in the state can use to determine the suitability of the project for using with accelerated bridge construction methods. So the way that this tool works is it actually considers all the project costs, but then there are some costs that can be offset or by there are the ABC cost, which may be higher than the conventional methods, can be offset with cost from some benefits of the ABC, for example, the safety benefits or social benefits or environmental benefits of the project. This is a quick screenshot of the CTDOT ABC decision matrix. That's again a spreadsheet, an Excel file, and the user needs to provide input values for the highlighted cells, as you see here. And then this is how basically this tool works. So we are actually looking, by using the Connecticut DOT tool, we are looking at two alternatives. Number one, use ABC. Number two, do not use ABC. So we're basically selecting between ABC and no ABC options. So Connecticut DOT is using 10 criteria for this decision making here. So as you see, the range of criteria here, it includes cost, as you see here, with the highest importance or weight factor. As you see here, it includes traffic conditions, user impact reduction. That's the time that the user or a driver spends because of that project. And then a wide range of criteria related to the location of the project, related to the design of the project, site conditions, and environmental and the existence of water work in the project. So then CTDOT uses some predetermined or fixed weight factors that shows the relative importance of these 10 criteria here. As you see here, the user impact reduction and cost are the most important factors here. And then finally, the tool calculates a final score for each project. It's called the final ABC rating score, and that's a number between 0 to 100. And the decision making is here. If the final score is below 50, that means do not use ABC. If it's above 60, the project is a very strong candidate for using ABC. And if it's between 50 and 60, that means further evaluations are needed, but ABC is still the case here that can be considered in the project. So this tool, while the Connecticut DOT tool is very practical, simple enough, and it's a very well-received tool, there are still some areas that we can consider for improvement. And more importantly, there are three areas that we considered as new criteria in this tool, and that's incorporating the safety benefits of ABC into the tool, together with social equity and environmental justice. And here is the topic of this presentation. I'm going to be talking about that more shortly. The other area for improvement is, as you noticed probably in the previous slide, Connecticut DOT is using some predetermined or fixed weight factors, but we are providing another option in this tool for the decision makers or for the users to systematically determine the relative importance of criteria. So with that, the objectives of this project is basically to incorporate these new aspects to the decision-making tool. We are quantifying ABC benefits for work zone safety and incorporated into the tool. We are incorporating social equity and environmental justice aspects into the tool, and we are incorporating a systematic method for determining the relative importance or weights of criteria in the tool. With these improvements, we're expecting, and we are seeing that we are expecting the tool to be still simple, because that's an important factor here. We want the tool to be used by the end users, by state DOTs. The tool is systematic, meaning that it's adjustable to different projects. And another very important factor here is that the tool is working based on readily available data. That means that any state DOT in the country should be able to use this tool. And finally, because of having that systematic method, the option of using the systematic method for determining weights, the tool is capable of group decision making, which is another important aspect of the new tool. So let's quickly talk about the relationship between ABC, accelerated bridge construction, and work zone safety, and why safety is important, and why increasing safety is a benefit from ABC. Well, basically, bridge construction projects are time consuming, and they include a lot of, works on the side, a lot of probably and that affect the construction process affects the traffic, a lot of detours maybe, or lane closures. And then there are some data, and these data are from the National Highway Traffic Safety Administration Fatality Analysis Reporting System, and that shows that the work zone fatalities and injuries in the work zones are really increasing. You do see the increasing trend from 2012 to 2021, and we do see like a 55% increase, for example, for the work zone fatalities here. And that shows that if we are able to reduce the construction time, it's not just reducing the construction time, it's actually improving the safety in the project, or reducing the risk of these fatalities, or risk of having crashes in our work zone here. Well, the relationship between ABC and social equity. Well, it might be a question to you how accelerated bridge construction might be related to social equity. So to answer that question, we first need to understand what actually social equity means in the context of urban infrastructure planning. And the answer to that is it's providing equal resources and opportunities by infrastructure systems for all urban communities. And that includes all community groups, including ethnic minorities, low-income communities, sensitive groups, including the elderly, the younger generation, and stuff like that. So the way that ABC can provide benefit here is different. So as an example, you can think about the role of ABC in reducing interruptions in accessing, for example, hospitals for communities with sensitive ages, with people with sensitive ages. And sensitive ages are usually defined as people younger than 5 or older than 65. So a lot of times these groups are in need of accessing hospital more than probably other age groups in the community. And by having accelerated bridge construction methods, we are providing less interruptions in the access of people. And we should understand that the final end user of all of these infrastructure, civil infrastructure, including roadways and bridges, are people. And we're doing this for people, so we should provide more social equity for people who otherwise, like thinking about low-income communities, don't have access to use personal vehicles, and these interruptions can impact them really disproportionately. The other ways that ABC can provide benefit is, for example, facilitating emergency responses in the case of for example, natural hazards such as hurricanes and floods. And that's important to note that a lot of studies have shown that the urban communities, the disadvantaged urban communities or underserved urban communities are disproportionately impacted by these natural hazards. So by providing ABC, we're improving social equity in that aspects as well. There are other benefits of ABC, including reducing the risk of vandalism and theft in construction projects that can provide reduced construction insurance costs, and also reduce the construction delays due to legal investigations. When we think about environmental justice, also we need a definition. And in this context, by environmental justice, we mean providing fair treatment and involvement of all people regarding environmental policies. And that's for an urban project, for an urban infrastructure project including bridge construction projects, that's providing the same degree of protection from environmental and health hazards to everyone in our specific case, including our construction crew and also the people who live close to our work zones. Because we know that some environmental factors such as the extreme heat or poor air quality, these are threats to human health. And these are threats to our workers and to our urban communities adjacent to the project. So by reducing the construction time, we are actually improving these aspects of environmental justice here. Recently, we conducted a project under the ABC UTC, and this is a recently published paper. We tried to develop a framework for incorporating social equity and environmental justice into bridge construction planning or prioritization of bridge construction projects. That's a very comprehensive work. For social factors in that project, we looked at 6 different data sets, including income, population densities, average commute time, and stuff like that, as you see on this screen. But in this project, this new tool is actually building on this study, this recent study for social equity and environmental justice. However, we understand that this new tool should be simple and practical, so we didn't use all of the 6 factors here for social equity and the 2 factors for environmental justice here. We only use 2 here, and that's the income and population density, and we'll be talking about that shortly in this presentation. So getting to the methodology for developing this new tool, it's actually an improvement to the existing Connecticut DOT decision matrix, and the improvements are in 2 ways. Number 1, we are adding a new decision criteria. Safety is being incorporated into the tool as a new decision criteria. Also, social equity and environmental justice, or we call it SEACH here, is being incorporated into the tool as a new index. And that's both safety and social equity. These are to the best of our knowledge, the first time incorporation of these factors into ABC decision making. And on the other hand, we are incorporating a systematic method as an option. We are still keeping the option of using predetermined weight factors, but we are adding this new capability to the tool to be used as an option. So the new tool, we try to keep it as similar as possible to the existing Connecticut DOT tool, meaning that it's still a spreadsheet. It's an Excel file. You can just open it similar to any other Excel file. And when you open the tool, this is the first page that you see here. You see multiple tabs here. The user needs to go one by one into each of these tabs and provide some input information. There's a link here that you can use to access the tool after this presentation. And again, in the near future, we are providing some step-by-step guidelines and training videos for you to be able to use this tool. We have called this draft. This works fine, but we called it draft because we're really interested in you using the tool and letting us know about your experience, or your feedback, if you have any comment, so we can improve the tool or we can address any comment. So with that, I'll turn it over to Nasim, and she will be providing you with some more details about the tool. Nasim, it's all yours.
Okay, so here I want to start with how we started with safety benefit quantification. And as it mentioned, ABC minimizes the work zone safe crash cost by reducing the number of days that the work zone is active. So you will notice that ABC typically might have some higher upfront costs compared to the traditional methods of construction. However, introducing this safety quantification benefits can offset these initial expenses in some cases. So the safety quantification approach we had in this tool is to calculate how much dollar returns to the project in terms of reduced crash cost. And this is built on the findings of previous work done at ABC UTC on the work zone safety analysis. You're very welcome to check them later with the provided information here. But if I want to go ahead and explain it shortly, the cost of the crash when the work zone is available will be multiplied by the days of the reduction in the work zone when we have the ABC, because definitely, typically ABC will reduce the work zone activity. And then that will be the percent of the crash, percent of the total ABC implementation in the project, which we call it safety benefit. To design the safety benefit tab in this tool, first we conducted a limited survey to gather some information on crash data from different state DOTs, and that was to understand how different state DOTs handle their crash data. The result of this survey showed that each state DOT, more or less, they established and updates their crash data for internal uses. However, there is not consistency in their safety crash data reports. For example, I can mention Arizona DOT or Kansas DOT. They have these open access available crash data. On the other hand, we have Alabama DOT, which doesn't provide geospatial crash data records online. Or, for example, Illinois DOT, they just give limited access for this crash data. Additionally, state DOTs, they don't follow the same crash cost analysis and report methodology. For instance, Kansas DOT has the statewide crash cost. On the other hand, Arizona and Montana DOT, they use the national crash unit cost. So to sum up, I would say later these findings helped us to design and adjust the safety quantification tab in the tool to make it more applicable to every state DOT nationwide. From what you are seeing here in this flowchart, there are two main data resources included for safety calculation in this tool. One of them is from state data records, and the other one is from national readily available data records. And the monetary value of crashes at the bridge's location will be calculated either from national databases or state specified databases. It's depending on the user's preferences and their availability. But from this methodology, the safety tab in the tool includes 4 standalone tables. The user just needs to complete one of the tables, so it's not mandatory to go ahead and fill all of the tables. Based on the data availability, the user will decide which data table they need to go ahead and use for safety benefit calculation. There is a matrix we included in the tool to help the users to choose the appropriate table number. The crash frequency and unit cost intersects table cell will define which table number should be used. For example, if we assume that crash frequency data is coming from national data resources, also crash unit cost is coming from national data resources, so table number 2 will be the appropriate table number for the safety benefit calculation. And also in the tool, we provided the useful data link for data inquiry for this tab and calculation. In addition to the safety, we also introduced the social equity consideration to the tool. Potentially, there are many criteria that could be considered here in terms of social equity, as it mentioned. However, to keep the tool simple, we just consider population density and income. You can see population density and income distribution map on this slide, which are coming from the urban development area of Miami-Dade County as a result of our previous study, as Dr. Brahimian mentioned. And I want to explain that area with high population density generally have higher traffic volumes. Therefore, lane closures or construction activities can easily cause significant disturbance. Also, traffic delays in this area will affect a larger number of people, which also leading to greater economic and social costs for the community as well as the construction project. This directly and indirectly cost also affecting the low-income communities because they will have limited access to health services, educations, or job, or any other services for the community when the construction zone and work zone is active. In terms of environmental justice, we introduce heat and wind chill index here to reflect the potential risk of exposure to extreme weather conditions, which can have also significant health impact on the community or even the workers. As ABC ensures that vulnerable people are more protected in ABC construction method from extreme weather conditions, that's why we introduce these two factors into the tool. Just to go over quickly, heat index measures how it feels on human body when there is a humidity along with the air temperature. And high heat index values can pose different health risks, such as like heat stroke or dehydration, especially for outdoor workers. And the wind index tells us how cold feels like when it's combined with the effect of wind. And you can see here different classifications of heat index and chill index values, which then we calculated in the tool. To quantify the social equity and environmental justice consideration we already talked about into the tool, we introduced the SIG index here, which is the weighted average of decision-making factors we have in each of these categories. So it will be population density, income score, heat or chill index, which then will be using weighted average method, give us the SIG index. And a higher SIG score indicates greater concern, which means that the area requires more attention in terms of infrastructure's planning. Here, ABC, that can be more helpful with those vulnerable areas. And as it mentioned, we also had another step in this FIU-ABC decision support tool, which is the last step in the tool to determine the relative weights or importance of the criteria. We included two different methods. One is predetermined weight, the other one AHP or analytical hierarchy process weighting, and it's completely up to the user which way they wanted to go ahead and use and apply in their decision making. If I want to start with predetermined weights, it's so straightforward, simple enough. User just need to go ahead and enter the predetermined weights they have from their organization or expert judgment. And also we included an example predetermined weights for the users in the case they want just use them. Also in the analytical hierarchy process, this is very well-known approach that has been applied in infrastructure planning a lot and in decision making a lot. And this is even more useful when criteria weights need to be adjusted or specified for any particular context, or when multiple stakeholders are involved in the project. So in this method, the user just need to fill the yellow cells using numerical scale from 1 to 9 based on a pairwise comparison. And I don't want to go ahead and explain details about it, but you are welcome to check the handouts later and also the video that we want to provide on the website for more details on how to apply the AHP method for weighting. So now I'm finished with the explaining the structure of the tool, and I want to go ahead and introduce the practical applicability of this tool using a case study. And this case study has some inputs that are the exact same input data has been provided before by Connecticut DOT in the in-depth web training in the module 5, which also we provided the link for you if you want to go ahead and look at the presentation itself. And again, that we are using the same input data for our case study. So at the end, we can compare the results with the Connecticut DOT tool. So this project is located in town of Kingley in Eastern Connecticut, and it is involving Interstate I-395 over Tracy Road, and it's very a rural section of Connecticut. With a closer view, you can see that here this bridge has 3 different lanes, which I explain later. But in this case study and this project, there were 2 different proposed replacement methods. One was conventional method and the other one was accelerated bridge construction. One thing to consider here is that this project was only proposed for replacement of the northbound structure of the bridge. And as I mentioned, this bridge is a 3-span concrete structure and has a fairly standard geometry. However, the bridge joints were problematic because of years and years leaking, which led to significant deterioration of many beam ends that make them to decide about this replacement of the bridge. And for the non-ABC construction method they proposed, that was actually a stage construction proposal, which was maintaining 2 lanes in stage 1 and just 1 way in the second stage. And the overall time of the construction was estimated 18 months. On the other hand, with the accelerated bridge construction, there was 7 days closure time proposed. So they can go ahead and build the bridge, and the estimated time was 12 months totally. And the idea was to do the majority of the work before the closure, so to limit the construction time and activity of the work zone in the bridge location. Here you can see the snapshot of the base calculation tab, which is the very first tab of the tool. After introduction, you can see the base calculation in the app, and this is exactly the same as what CTDOT decision matrix has. This tab includes 4 different tables itself, which are standalone tables, and each of them calculating 10 different criteria that CTDOT matrix has. And we are going ahead looking closer at the definition of those criteria. One of the important criteria in this tool we have is user impact reduction, which is basically accounts for additional delays due to high traffic volumes because of the construction. And it can be also because of stop signs or congestions. To calculate the user impact, a delay time is needed, and for calculating the delay time, there are a lot of complicated methods or simulations. But the good thing about CTDOT decision-making matrix is that they use the congestion factor, and the tool itself, based on the access limitation time, will calculate the delay time, which makes it really user-friendly and straightforward. So for this case study, we have 1 road over the bridge and the other one is under the bridge. As I mentioned, the first stage was proposed to have no delay, while in the second stage we had 1 reduced lane. And in the reduced lane was about 75 days estimates. Therefore, the average daily time per vehicle will be calculated per minute as 1.6 minutes for the first option. And if we use the ABC method, we have just 1 detour option for that 7 days closure time, which gives us the average delay time to be 14.7 minutes. And that at the end will give us the final user reduction for ABC, which is 13%, which means that accelerated bridge construction will be impacting the user time up to 13% less than the conventional method. Now let's look at the cost here. Going through the calculation, we see here an 8% increase in the construction cost when we go to ABC, which means ABC is 8% more expensive here in this case study. And again, you can go ahead and look at the details more with the links that we provided. I'm just going ahead fast. In addition to these two factors are explained here, there are 8 more factors included in the CTDOT decision matrix, and each of them will get a score. For example, some of them, one of them is related to the bridge location, how it's close to like hotspot, like for example a hospital, or a measure of a design complexity, also work zone geometry, and site condition, how it can limit the construction for the ABC construction. And if we have any kind of waterway limitations, any waterways beneath the structure that might affect the users. So after giving any score based on the construction, the project construction, finally, based on the CTDOT decision matrix, we ended up to the ABC rating 44, which put us into the don't use ABC here in this project. Here I want to emphasize that this approach potentially is missing out on the benefits that ABC can offer in terms of rapid construction, because we are not focusing, or we are not introducing safety and social environmental consideration so far here. But let's go forward and look at the integration of safety quantification and siege index into the tool and see how they impact the result. So when we go forward in the tab, we see the safety tab, which is coming with the safety instruction before, so users can use the safety instruction and the guideline there for data inquiry and entry into the tool. As you can see here, the safety tab includes 4 tables, but again, users just need to complete one of them based on the crash data availability they have. And this matrix will help them, as I explained before. For this case study, I assume that we are having data from both national databases for crash frequency and crash unit cost. So ended up using table number 2. And also we have access to data link that we need for the data entry through the tool. So you see the snapshot of the safety tab here. We have table number 2 here, and the users just need to complete the yellow cells. And the only thing they need to look here is what kind of data they need. The user will find out that first they need to put the calculation year they wanted to do the calculation for, and then the crash frequency data is needed here. After putting the crash frequency data, the tool will automatically apply the national crash unit cost. However, because this is based on the 2016 national unit cost, adjustments is needed for inflation, and also state adjustments are necessary. So to do that, we need 2 more data, which is per capita income data and consumer price index. I explained the crash frequency data inquiry from the national crash databases just quickly. We have the link provided in the tool. Users will click on the link and then navigate to the website. There on the website, they will click on the crash map, and then just with clicking on the location of the bridge, or even by putting the zip code or the address, they can find out the bridge location. Then they need to just count the fatal crash data and put them and enter them in the spreadsheet that we provided for them. And it should be done for 3 different years that they want to do the calculation for. Here, we just did the calculation for our case study for 2020, 2021, and 2022. As you can see, the frequency data are provided here. Now we need to have another data here, which is per capita income for the adjustment to the state. To do that, again, the link is provided in the tool. By clicking on the link, the user will navigate to the website there. Based on the state and the area, they will choose the state, and then the time frame will be chosen here. And then they will click on the next. They will go on the time period, and then at the end they will read the per capita income for the 3 different years they have in the tool for the calculation. So they will the user will enter the per capita income into the tool, and then the next information we need here for the inflation adjustment is consumer price index. To do that, again, the link is provided. They will just go ahead and do the same thing, clicking and then reading the data from the website, put it into the tool. And then at the end, for this specific case study, after the calculation, the safety benefits quantification gives us 62% safety benefits, which shows the percentage of total savings of total ABC implementation costs. So even though ABC is costly in this project, for total ABC cost, there is 62% return in terms of reduced crash costs because of accelerated bridge construction application in the project. And then we want to introduce the siege index to the calculation. We have the introduction, help the user with the guideline, and provided the links for data inquiry and data entry. One of the data we needed is population density. They will just, again, clicking on the link. It's so straightforward, looking for the bridge location and copying, pasting that into the tool. And then the tool will give that automatically a category from 1 to 5. And higher the number is higher the vulnerability for that project location. For per capita income, again, using the readily available data link provided, the user will get the information for the per capita income and put it into the tool, and then that will give us another category number automatically, and the social equity factor will be calculated here automatically for the project. Then we go for the environmental justice calculations. 3 different data is needed here: temperature, relative humidity, and wind speed. All of them will be captured from website from NASA, and that will be easy, again, like the other ones, clicking straightforward. It's readily available data. So the detailed information is provided in the guideline and the video that will be provided later for the tool. I'm just going ahead explaining quickly. So after choosing the selecting the data that we wanted from the website, user will download the information and they will come up with Excel file from the website that's giving them the information we want. And this Excel file have annual average information for each of the data that we want. For example, for the relative humidity, we have data for 5 different years. So just copying and pasting this information into the tool, pretty straightforward and simple, and then the tool will be calculated based on the calculation that will decide, that will give the information if the heat index or chill index is applicable to the location, and then also give it another score from 1 to 5, higher the number, more vulnerable. So another step here, which is the last step, is the weight assignment. And I explained it already for you that is predetermined or AHP. In this case study, we use the predetermined weights, and we just copy paste the predetermined weight examples that we include into the tool. And then you can see here two tables that we have for each of these methods. And these yellow cells are completed with numbers with the user. So at the end, with using the predetermined weights for this case study, we ended up with 3 different results, and that will shows how the integrating safety and siege can affect the decision making. I want to go back to Dr. Brahimian for further clarification and explanation on this.
Okay, all right. Thanks, Nassim. Can you hear me?
Yes.
Okay, so well, I'll try to wrap up the presentation. We are probably a little behind, but just to give you a quick note here, what you see here is the comparison between the results. In the very left, on the left, you see the results based on the existing CTDOT tool. The final score is 44, simply meaning do not use ABC. If we just use safety, the middle one, the middle table, the score, the new score will be 58. 58 is pretty close to 60, and it gives us, you know, the hint that hey, you should really, you can really think about using ABC here. And then finally, by adding both safety and social equity, environmental justice, the new rating score is 60, which shows that this is a really, you know, more stronger candidate for ABC. So we can really think about using ABC for this project. So this simply shows the effect of, or the potential effects of safety and social equity, environmental justice in changing the decision-making outcome. And here we just use the same factors, the same weight factors that the original example by the CTDOT used, and we just added new predetermined weights for safety and siege index, as you see here. Next slide. So just to conclude, this was the first time incorporation of quantified ABC benefits for improving work zone safety, and also in ABC decision making, also the first time incorporation of aspects of social equity and environmental justice in ABC decision making. We provided an option. We didn't talk about that here in this presentation, but using the AHP method is an option here that can prove that together with other aspects of this tool, which is using the nationally available data, that gives us the capability to use this tool across the country, meaning that this tool can be applicable to all the state DOTs, because we're using nationally available data, and each state DOT can use their own weights, or they can use a systematic method to determine weights. The tool is still simple, it's Excel based, and it's adjustable, meaning that we can change the weights here. We can also in the future add or delete decision criteria and provide group decision-making capability as well. So, well, this was our first try of including safety and social equity, environmental justice here, but we are really expecting the end users of the tool, which are probably state DOTs across the country, to use this tool in real applications and provide us with feedback. And hopefully we are able to hear back from you and see how we can even further improve the tool. The tool can be further improved to provide less qualitative evaluations. One other aspect of improvement could be providing the benefits of ABC for reducing greenhouse gas emissions, contributing to climate change mitigation and adaptation. And last but not least, as you probably noticed here, this is a semi-automatic tool. A lot of time you need to go, all the data are available from national databases, but the user needs to go to the national database, click on the link, copy the data, paste it here in the tool. But this process can be automated. So we can provide, so if there's an interest from, for example, FHWA or multiple state DOTs, we are happy to put together a new project and provide really an online tool that automates the whole process here. So with that, I'd like to wrap up the presentation by acknowledging a lot of people who helped throughout this project: ABC, IBT, ABC, UTC for providing the funding, my co-PI, Dr. Mantawi from Rowan University, and a big thank you to our research advisory panel members who are from 9 state DOTs across the country. They listened to our presentations, they reviewed our report, and they provided us with feedback. Thank you all. And finally, thank you for your attention, and we are happy. This is the conclusion of this presentation. We are happy to take any questions or comments.
Great, thank you, Ali and Nassim. That was a great presentation. We do have some questions that came in both before and during the webinar. So now I will turn the presentation over to Jamal Al-Kisay with Federal Highway Administration, who will start the Q&A part of the seminar.
Ali and Nassim, this is a really great presentation on the decision-making platform. This is for the state DOTs. This is the first step to decide whether they're going to use ABC or not. So it's been going through evolution process, and your enhancements here add on to already Connecticut DOT decision-making tool. So here we have a few questions that came in pre-webinar, and then we have also more questions came in during the presentation. So I will start with the pre-webinar questions. And the first question was, why would quantifying safety be important to bridge owners?
Okay, I can provide some quick input on that. Well, basically, one of the major advantages of using ABC is to reduce the construction time. And reducing the construction times simply means reducing the number of days that people, vehicles are passing through the work zones, and also the less number of days that the construction crew are on site and are working. And every time that each passenger, each construction worker is in the work zone, there's a risk of crashes, there's a risk of injuries and even fatality for that. By reducing the construction time, we are actually reducing the risk of those crashes, injuries, and fatalities. And this is one big aspect of ABC or accelerated bridge construction that can be considered in decision making.
That's a great answer. The second question, you already covered that during the presentation, but maybe you want to add on. If a bridge owner wanted to quantify improved safety, social equity, environmental justice, how you suggest to get started?
Well, basically, this is an interdisciplinary or multidisciplinary problem. So similar to any other multidisciplinary problem, you need to have people from different areas to work together to address these sort of problems. And this is not different than any other multidisciplinary problem, meaning that we need to have people who are aware of the technical aspects of the project, structural, traffic, and also we need to have people who are working on data related to safety, crashes in the state, and also to social and environmental aspects. So that's one thing. So basically, probably the first step is for the state to put together a multidisciplinary team to work on this. However, one note that I wanted to really mention here is that the tool is really simple. So even though it needs a multidisciplinary team here, the level of expertise could be minimal because it's a pretty straightforward process, and there's a guideline that tells you go to this resource and just click on this, copy this, and paste it in the tool. So we're trying to help increase the applicability of this tool in real bridge construction projects.
That's great. And as you mentioned, it would be automated in the future. It could be automated in the future, and that would make it more easy for them to use.
Well, it's my hope if there's funding and interest from relevant organizations, we are more than happy to do that. It's just it just needs a new effort to automate the whole thing.
Okay. The third question I have here, if somebody wanted to use the tool, can he use the 1-factor or 2-factor or the 3 factors together combined, or he has to use all 3 of them together?
Well, the answer is you can use just the existing tool. Even if you're using the FIU-ABC tool, it's building on the Connecticut tool, so you can just use the CTDOT tool, but you have the option of adding safety only or adding both safety, social equity, and environmental justice here. So it's up to the user which one to use.
And the tool is equipped to use either 1, 2, or 3 enhancement, the enhancement that you mentioned, which is
Yes.
Which is okay, safety, social equity,
Right.
and environmental justice.
Correct.
Okay. There's one more question. Did you have Connecticut DOT involved in the process of developing the enhancements?
Well, the answer is yes, definitely. That was our start point. We put together a technical advisory panel for the project. Like I mentioned, we had 9 different state DOTs, including Connecticut DOT, and we had an expert from the Connecticut DOT on the team who reviewed the project deliverables and the tool as well.
That's good. And the last question that came in pre-webinar is, does someone wanted to use the tool need to get Connecticut DOT or FIU approval to use the tool? And is there any cost associated with that?
Well, not really. No. Well, we're making the tool available to everyone. We are uploading the tool. I provided a link in my presentation, and you all have access. The audience have access to the slides, so you can just click on the link, go to that page, and download a copy of the tool. That's just an Excel file, and you can use it for your project. So no approval is needed here. If there is any issue or if you have any comments, you're more than welcome to reach out either directly to us, me or Nasim. Our email addresses are here on the screen right now. You're also more than welcome to contact the IBT, ABC, UTC, and they probably, if that's something technical, they will refer it to us, or if something they can address, they will do that for you.
And there would be no cost,
No,
cost with that.
No, that would be free of charge, accessible to everyone.
Good, Ali, and good, Nasim. Now I'm going to turn it to Paul to go over the question received during the presentation. Paul?
Thank you, Jamal. Can you hear me? Can y'all hear me?
Yes, we can.
Okay,
yes,
good.
We can.
Yeah, we have one question here that came in during the webinar, and we do have a few minutes. I may ask a question after that. Let's see, what if the tool shows ABC is better, but the project does not have enough money to pay for the higher ABC construction cost of 8%?
Well, I don't think I can directly speak to that. What we are trying here to do here is to see, yes, well, number one, the way the Connecticut DOT tool was developed, it considers ABC an option when ABC is up to 30% higher in total cost. If it's 35%, 40%, there's not going to be a comparison. That's no ABC. So we are talking about, you know, a cost difference in the range of up to 30%. So in this case, like 8%, what we are trying to say here is that, yes, it's, well, obviously, if you just look at the construction cost, it's 8% more expensive, but there are other costs that you are paying. And if you can quantify other costs, like how can you quantify the safety? Because that's important. Like if you can go with that, but the safety, but the injury risk, the fatality risk is much higher in the no ABC option. And if you quantify that risk and bring it into the decision making, then you may want to reconsider your decision. However, again, the final decision of what to do is not being made by this tool. This is a decision support tool. It's the intent here is to support decision makers to make the best decision and the final.
Yeah, let's see. What my question here was, when you're looking at your total score, which is just a sum of all those things, if you're over a waterway, 0 is going to give you 0 there. If you're not over a waterway, it's always going to give you 0. Is that correct?
Oh, actually, no. The tool is designed to have it not applicable if we don't have the waterway handling in the situation. So
Okay.
it comes to the calculation when we have in water application, but then how much it affects the project. When it doesn't have anything, it's not applicable.
Show the last slide with the 3 tables
okay.
when you have not applicable.
Mm-hmm. Yes, that's actually
Okay,
what we added. Yes.
Yes.
Okay.
Yeah.
Okay, but then the criteria on acceptance or not acceptance, does that take into account the elimination of the waterway? In other words, your score has got to fit into those brackets. Does it work it out? I don't know that. All right, now you got a total score. What did you get? You got a score
44. You mean?
44. Now, if that would have been over a roadway and it would have had just a little bit, it probably would have gotten up to, might have gotten up to 60. Is that possible?
Oh, actually, yes, that's something because with the crash data we introduced to the tool, we used into the tool, that was just fatality data. So because the fatality data is compared to the other categories of the crash type has much higher values, so that affected a lot to the project.
Okay, but I'm looking at the waterway limitations.
Waterway, that wasn't applied.
I know, but if it was 5%, and just suppose you had a limitation of 10, then that would have given you, multiplying it out, would that have pushed it over the 60% or the 50%? Because you're at 44 now.
Well, it's possible. Again, well, the way this is from the original tool, this the waterway limitation.
Yeah, I understand.
Yeah, if you have a waterway that will be impacted by the project, including changing, for example, the cross section of the waterway, which is not good for flood considerations, or if you're polluting the waterway. So these are bad things. So we want to reduce the impact that the bridge construction projects will have on the waterway. All right. So depending on the situation, how the waterway is going to be impacted, this can get a score of 1 to 5. Here it was not the case, so the score is 0 here.
Well, you were not over a waterway.
Yes, exactly. So
my
if
question,
we have a my
question is,
right,
by having a waterway or not having a waterway, does that 44%, if you had a waterway, would the 44% go up enough to kick you into the higher category of consider or use?
Well, it's a simple calculation. It's a simple calculation because the maximum score for the waterway could be 5, right? Okay. Then we can just simply, Nassim can do that right now with the tool. It's just 5 times 5, that's the adjusted score. Yeah, and then 25 plus the total score would be 229 over the total adjusted score, whatever that is. I don't think it gets to it gets much higher because it's just 5% weight. Okay. You're probably still in the no-go zone for ABC, but it will definitely, if it gets a score of 5, it will definitely increase the final
Okay.
ABC rating.
Now that's curious. I just wondered if you were being penalized by not being over a waterway.
Right.
Okay. No, that's fine. That's all the questions we have, I think. Yeah. And so with that, I'll turn it back over to Kathy.
Great, thank you, Paul. So thank you again, Ali and Nassim, for really an excellent presentation and for your valuable and really immediately implementable research. It's really going to help the industry. So to the audience, please join us for the next quarterly research seminar, which is on October 25th from 1 to 2:15 p.m. Eastern Time. The topic will be large-scale implementation of semi-proprietary UHPC with recycled fibers. Again, thank you for joining us today. This quarterly research seminar is now complete.
Thank you.
Thank you.
Thank you so much.